Hello, welcome to today's class. Today's class will also be on intelligent agents. In the last class, we talked about rational agents and we also talked about task environment and the piece description also. In today's class, we will talk about the different dimensions along which task environments are categorized. And knowing these dimensions is important because it would help us to determine the correct design for agent that we are thinking of. So if we want to develop a agent for a particular task environment, and if we know to which category our task environment belongs to, that can help us to choose from some standard family of techniques that are available. The technique to use depends on the category that the task environment belongs to. So that way we can, knowing the category helps us to design our agents. Now what are the different categories? The first one is whether the environment is fully observable or partially observable. So what do we mean by fully observable is if the sensor of the agents give access to the complete state of the environment at each point of time, then we call that environment is fully observable. Otherwise, it's partially observable. So some example of partially observable environment is if we go back to our vacuum cleaner robot, and now if that agent can sense only the local dirt. What we mean by that is, suppose the robot is in room B and it can know only whether there is dirt present in room B or not, and its sensor do not tell the robot whether there is dirt present in room A or not. In that case, this environment is a partially observable, because we don't have the complete knowledge. We don't have the knowledge of the complete state. We only know about we only sense only a partial environment. So it's a partially observable environment. Similarly, taxi driving is also a partially observable environment because we cannot see what the other drivers are thinking. Now it may be the case that the agent have no sensors at all. In that case, the environment is called unobservable. The next category, the next dimension for categorizing task environment is single agent versus multi-agent. It would be more clear using an example. So if we have an agent that is trying to solve a crossword puzzle, then this environment would be a single agent environment. However, if we have an agent which is trying to play chess, then this is a two agents are involved, the agent who is playing chess and its opponent. So this environment is a multi-agent environment. Now multi-agent environment can be further categorized as competitive multi-agent or cooperative multi-agent. So in case of chess, if my opponent is doing good, it indicates that my performance is bad, and if my performance is good, it indicates that the opponent's performance is bad. Such kind of an environment is called a competitive multi-agent environment. However, in case of taxi driving, um, one of our performance measure is how safely we are driving. Are we getting into accident or not? And if you consider that aspect of performance measure, then if the other um, driver is performing good in the sense that it is not getting involved into accident, then that is good for me also, because it will improve my performance also, because I will also not get into accident. If the other driver is driving safely, that is good for me. So that's why it's called a cooperative multi-agent. Whereas chess is competitive multi-agent, taxi driving is cooperative multi-agent environment. The next dimension along which task environments can be categorized is deterministic versus stochastic. So deterministic environment are those in which the next state of the environment is completely determined by the current state and the action executed by the agent. Otherwise, it's a stochastic. Example of a stochastic task environment is taxi driving, because the state of the traffic in the next moment of time is not determined by my action only. Whereas in case of the crossword solving agent, what would be the next state of the puzzle determines only based on the action that the agent takes. So if the state of the puzzle will change based only on the action of the agent. Usually, if the task environment is partially observable, then it would be a stochastic also. Now an environment is uncertain if it is not fully observable or not deterministic. So if it is not fully observable or it is not deterministic, then we call it uncertain. The next dimension along which we can categorize task environment is episodic versus sequential. So what do we mean by an episode is, let's say agent receives a percept through its sensors, and then it performs a single action. So that constitutes an episode. To give you an example, in case of agent playing chess, the agent makes a move. Let's say it moves its pawn to some square. That's one episode. In response to this move by the agent, the opponent will make another move. That's the next episode, and so on. Now, if a task environment is episodic, then the next episode does not depend on the actions taken in the previous episodes. An example would be a robot that is trying to pick defective part from an assembly line. If the robot pick a defective part, that would not determine what it would do for the next part. The action that the robot will perform for the next part is completely independent of what the agent did for the previous part. Hence, that task environment is episodic. If the task environment is not episodic, then we call it sequential. Now, playing chess or driving taxi, these are examples of sequential task environments, because the action that we perform currently will affect how I will behave in the next episode. So what move I make in the current episode will determine what other moves I can make in the next episodes. Similarly, driving taxi, the current move that I'll make while driving the taxi will determine what future moves I can make. The next dimension along which we can categorize task environment is static versus dynamic. So dynamic environment are environments which can change while an agent is deliberating about the next move or the next action, and those kind of environments are called dynamic environment. Otherwise, it's a static environment. Example of a static environment is the crossword puzzles. So when the agent is deliberating about the next action, it is thinking about what would be the next word to put into the puzzle, and the state of the board will not change when the agent is thinking about the next word. So it's a static environment. Whereas taxi driving is dynamic, because while I am thinking of what action I should take, during that time the state of the traffic is changing. So it's a dynamic environment. Now there is something called a semi-dynamic. What it means is that as I am thinking of the next action, the state of the environment will not change, but the longer I take to take my action, it would degrade my performance. For example, if we are playing chess with a clock, the longer time I take to make my next move will reduce the amount of time I have in my clock. So it will affect my performance. Hence, playing chess with a clock is semi-dynamic. Next dimension along which we can categorize is discrete versus continuous. The discrete continuous distinction applies to the state of the environment, to the way time is handled, and to the percepts and actions of the agent. Example of a discrete environment is playing chess. So the chessboard has only a finite number of distinct states. It may be a very large number, but still it is a finite number. What we mean by that distinct state is, let's say one state could be I have my pawn in square b5 and my rook in square a1. That's one state. There may be other piece also. Another state would be that same pawn is in b6 and my rook is in a4. So that's a different state. So different position of my piece. So like that I can have different states of the board. In chess, the number of different states would be very large, but still it is a finite number, and hence it is a discrete environment. However, in case of taxi driving, if I consider my speed, the speed is a continuous value, and there can be infinite possibilities. For example, I may be driving in a speed 20 km per hour, or it can be 20.5 km per hour, or it can be 20.55 kilometer per hour. Like that I can have infinite possibilities, and hence taxi driving is a continuous environment. The task environment for taxi driving is a continuous environment. Even my steering wheel, by what degree I will rotate, that value of the degree is a continuous value. So taxi driving, the environment for taxi driving is a continuous environment. And the last, actually this is not a category for the task environment. It's a known versus unknown. It talks about the agent rather than the environment. So it refers to the agent's state of knowledge about the environment. It will be more clear through an example. So if we have an agent which is playing a video game, and now if we have a new video game, the agent would not know what are the different functions of the different buttons until the agent tries out the game. So that's an example of an unknown environment. So it's not a factor of the environment itself, but it's about the agent's knowledge of the environment. Now we have seen all these different categories, different dimensions along which we can categorize task environment, and the most difficult case is when your task environment is partially observable, when it is multi-agent, stochastic, sequential, dynamic, continuous, and unknown. So all this combined makes a task environment most difficult. And taxi driving, the environment for taxi driving is such a task environment, which is partially observable. It's multi-agent also, it's stochastic also, it's sequential also, it's dynamic, continuous, and unknown. And that makes developing an agent for the taxi driving environment a very difficult task. This table shows the different task environments, and it also shows in which categories the task environment falls. For example, the crossword puzzle is a fully observable environment because the agent who is playing can view the puzzle exactly, what is the current state of the puzzle. It's a single agent environment. It's deterministic because how the state of the puzzle will solve is determined by the action of the agent. So it is deterministic. So if the agent puts a word into the board, it will change the state of the board. It's also sequential because what word I put will affect what other words I can put in the next moves. It's static because as I am thinking about the next word, the state of the puzzle will not change. And it's a discrete because it would have only a finite number of states. Similarly, the categories for other task environments are listed. You may go through it, and if you have any questions, you can ask during our question or answer session. Of course, it depends on how you think the environment as. This is not a hard and fixed categories. For example, medical diagnosis is mentioned as single agent. However, it can be multi-agent if you consider the other people involved in the task of medical diagnosis. So it's not an hard and fixed kind of category. It depends on how you are thinking of the environment. If you go through that part of the book, it also says that you can consider medical diagnosis also as multi-agent. If you read that section, you will find it out. So it depends on how you think about the task environment. If you consider few aspects, it may be single agent. However, if you add other aspects into the task environment, it may become a multi-agent. But I hope you have understood what are the different dimensions, what's the meaning of the different fully observable, partially observable, single agent, multi-agent, and deterministic, stochastic, episodic or sequential, static or dynamic, discrete and continuous. If you have any questions, we'll go through it in the question answer session. That's all for today. We'll meet in the next class. Thank you. Bye.